Then we're going to be looking at solving equations using some properties of logarithms. Looking at our first example here, we have the log base 6 of x plus the log base 6 of x minus 9, that's equal to 2. Remembering our product property, we can go back and put these two things together. This becomes the log base 6 of x times x minus 9, and that's equal to 2. So, now I need to remember way back and remember that, oh, with my logs, this right here, and this can actually go together to form 6 to the second power. And this over here stays just as it is, x times x minus 9. At this point, we need to distribute. We'll send that x into our parentheses. So go in here. So x times x, that gives me an x squared. X times a negative 9 gives me a negative 9x. And that's equal to 36. At this point, we're going to take and subtract 36 from both sides. So minus 36, minus 36. I'll go through here, and I now have x squared minus 9x minus 36 is equal to 0. At this point, I need to factor. So I'm going to come over here to the side and say, hey, what can I multiply to get a negative 36, but add to get a negative 9? I start thinking about the factors of 36. Well, if we need to, we can go through and list all those out. I have negative 1 times 36, 1 times negative 36. I have negative 2 times 18, 2 times negative 18. I have negative 3 times 12, and I have 3 times negative 12. I have negative 4 times 9. I have 4 times negative 9. I have negative 6 times 6. So I'll look at these and try to figure out which one of these pairs will go through and give me a negative 9. Oh, look here. We have a winner. Winner, winner, chicken dinner. And since my leading coefficient's 1, I'm able to just go and drop straight down here to this and get x plus 3, x minus 12. Now that I have this, I can go and separate my factors. 2x plus 3 equals 0. X minus 12 equals 0. The one on the left is a minus 3 minus 3. So I have x equals negative 3. The one on the right, I'm going to do a plus 12 plus 12, which this gives me x equals 12. So I have two different answers. Now at this point, I need to go through and check. We got to go and check them and make sure they are good. So let's do a quick check. So to check them, I'm going to go back to my original problem, which was log base 6 of x plus log base 6 of x minus 9 is equal to 2. So I'm going to check first the x equals negative 3. So my x equals negative 3, so that's going to give me the log base 6 of negative 3 plus the log base 6 of negative 3 minus 9 is equal to 2. Then we look at that and go, wait a minute, this can't be negative. So therefore, this one is not a valid answer. So let's come over here and check my other one. Hopefully it works out okay. I'm going to check this time. X equals 12. So I'm going to do log base 6 of 12 plus log base 6 of 12 minus 9. That equals 2. So this gives me the log base 6 of 12 plus the log base 6 of 3 is equal to 2. So this is going to be the log base 6 of 12 times 3. So the log base 6 of 36. Here we have 36 is equal to 6 to the second power, and yes, that is true. So this is a valid answer. But these you always need to go through and check, especially if you get more than one answer, and make sure that they are always valid. Looking at another example here, in this example we have 2 times the log base 7 of x is equal to log base 7 of 27 plus log base 7 of 3. On the left-hand side, I'm going to use my exponent property, and I'm going to rewrite this one as the log base 7 of x squared. On the right-hand side, we're going to use our product property. This is going to be log base 7 of 27 times 3. So I'm going to go through and do my multiplication on the right-hand side first. So log base 7 of x squared is equal to log base 7 of 81. Since these two pieces are the same, I can then just say, hey, x squared is equal to 81. Now, take the square root of both sides, and I get that x is equal to 9. Our last example we're going to look at with these types of problems. The log base 6 of x plus the log base 6 of x plus 5 is equal to 2. It's similar to our first example here. We're going to first use our product property, and I'm going to rewrite this one as the log base 6 of x times x plus 5 is equal to 2. I'll write this back in exponential form. This is going to become x times x plus 5 is equal to 6 to the second power. I need to distribute this x right here. He's going to go into here. Getting all hooked up. So x squared plus 5x is equal to 36. Let's go through and subtract my 36 from both sides now. So minus 36 minus 36. Here I have x squared plus 5x minus 36 is equal to 0. Come to the side here and say, hey, what can I multiply to get a negative 36, but add to get a positive 5? We can go through and list all of our factors like we did just a second ago, or we can go, hey, I know I got a 4 and a 9, so let's look at the factors there. I got a negative 4 and a positive 9. I've got a positive 4 and a negative 9. Oh, I think the top one's going to be my best bet. Leading coefficient's 1, so I can drop straight in. So x minus 4, x plus 9. Here, set each factor equal to 0. X minus 4 equals 0. X plus 9 equals 0. Add 4 to both sides. X equals 4. Over here, subtract 9 from both sides. X equals a negative 9. I can't put a negative 9 in because that would give me log base 6 of negative 9. That is not a valid solution. Therefore, our only solution is this one right here. Dealing with our properties of logarithms, properties of logarithms, You need to always pay attention to what you're doing. If you need to, have the properties sitting out so you can look at them. And as always, good luck.